Welcome to Geometry Pre-AP with Schroeder. Today we're going to do Chapter 10, Section 5, which is applying other angle relationships in circles. So this unit's been all about circles and its arcs and angle measures inside circles, and so we're going to continue with that theme. So our first theorem for today is if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So if you remember, we have that table of all the different arc measures and stuff like that. So I'm going to bring that up. It looks like this. And so the one they just talked about is if the angle is on the circle. So this is the one we're talking about with that theorem. So this vertex of this angle is on the circle, so it's the angle is equal to arc divided by 2. This is the one we talked about the other day where it's an inscribed angle. So this was an inscribed angle. This was a central angle. You need to know what these are called. Okay. And so this is the one we're doing right now. So if the vertex is on the circle, it's the angle is equal to this arc that's on the inside of the angle divided by 2, whatever it happens to be. Okay. All right. So if we go back to our notes, the angle number 1 here is the red arc divided by 2, and angle number 2 here is the blue arc divided by 2. Okay. And so then here if we look this one and we want to find angle 1, we know that angle 1, so the angle is equal to the arc 130 divided by 2. So when I do that work, I get 65 degrees. Over here, we want to know what is the measure of the red arc. So the angle, which is 125, is equal to the arc we don't know divided by 2. And remember, this is a proportion. We can put it over 1, cross multiply and solve. And what we get here is we get the measure of KJL is 250 degrees. Remind yourself, what kind of arc is that? You should be able to say that that is a major arc. Okay. And so now we go on to different ways that lines can intersect a circle. So if lines intersect and they're on the circle, we get what's called an inscribed angle. Here, if the lines intersect in the circle, we just get an angle in the circle. Does not have to be the center. Not the center. Because if it was the center, then it would be a central angle. And then we have here where the lines intersect outside the circle, and we just have again an angle outside circle. And each one of these gives us a different situation, and they can create different types of formulas to work on how to find the measures of the arcs or the angles, depending on the situation. And so we covered the first one here already. We have not really covered this one and this one, which is what we're going to pick up today. And there's lots of ways these pictures can be drawn. They don't necessarily have to intersect a circle in 2 places and stuff, so we'll talk about those. All right, so our next theorem here says that theorem 10.12 says that if 2 chords intersect inside a circle, this is not the center, okay, it's just in the circle, then angle 1 here is the red arc plus the blue arc divided by 2. So 1/2 of that. All right, and if we want to look at angle 2, it's AD plus BC. So if we go to our chart, okay, so that's theorem 10.12. So this is 10.12 right here. 10.12, which says the angle is equal to the arc plus arc divided by 2. So we're talking about that little angle right there is equal to the 2 arcs. It's the arc and it's vertical angle arc. All right. And then this last one says angles outside the circle. So where was the vertex for 10.12? It was inside the circle, not the center. If it was the center, it would be a central angle. Okay, so this one, the vertex for the angles is outside the circle. And so for all 3 of these, this is the first one is a secant and a tangent. The second one is 2 tangents. This is 2 secants. But again, the angle is always outside the circle. And so what we do for that setup is we have this one right here, 10.13, which basically just says the angle is equal to the arc big minus the arc small divided by 2. And this is always the small and this is the big. The closer it is to the angle, the smaller it is. And so small and big arc. And so it's only got 4 setups here. We've got angle equals arc divided by 2, angle equals arc plus arc divided by 2. And then angle is equal to arc big minus arc small divided by 2. So this covers almost every situation you could have. Now, let's go back to our notes. So let's practice this a little bit. So here we have an angle. It is in the circle. It's not the center, because if it was, then these two right here, this and this, would probably be congruent, and they're not. And so that tells us this, the angle's not in the center. Okay, and so then we know that since it's in the circle, it's going to be arc plus arc divided by 2. So if we look here, angle X is going to be the measure of JM, which is this red arc, plus LK, which is the blue arc. And it has times 1/2. I like to do it over 2 because it's just easier to work as a proportion. So if you look at my setup, mine looks like this. X equals 130 plus 156 all over 2. You can even cross multiply that, so 2x equals 286, and so therefore x is equal to 143. And of course we can check our work, and there it is, 143. So angle x, the x is 143. All right. You need to be able to work these problems even if these angles were replaced by algebraic expressions. So if I took out the 156 and put 2x minus 4 or some sort of algebra expression like that, you should still be able to work these problems. All right, so practice this one. Pause the video and see how you can do. Okay, so let's see how you did. There's your solution right there. Oh, it's the same problem. I guess you don't get to do that one again. All right, so here we go. Here's a different one. All right, so here we have the vertex is outside the circle, so it's out here. And since it's out there, it's going to be angle equals arc big minus arc little, all divided by 2. That's the easiest way I like to write them. Put that over 1. And so then we get x is equal to 178 minus 76, all divided by 2. 2x equals 102, so x is equal to 51. Of course, I can move this out of the way. And, yep, it's the same answer. So again, these just have angle measures right now, and so we'll have some problems like this, but eventually it'll move into an algebra concept where we'll replace these 178s and 76s and x's with variables in expressions. All right, so try these 3. Pause the video and try to work these 3. Okay, so now that you've started the video back again, let's check your answers, see how you did. And so remember that our setups here should be angle equals arc big minus arc little all over 2 for all 3 of these. And so if you had some problems working these, usually what happens here is this one right here is where we have the most issue. Okay, so the angle is 34 equals the arc big, which is 3x minus 2, minus the arc little, which is x plus 6, all over 2. And here's your issue right now. If you got this one wrong, here's what you need to go look at. You got to put those in parentheses because each one represents a separate angle. But what does that negative sign right there do for us? That's a big issue right there. That little negative sign means that we have to distribute a negative. So it changes to a positive, this changes to a negative, and that changes to a negative. And that's probably why you got that solution wrong, is that you probably did not make those changes. So check your work and see there. All right, so here's a toughie. Pause this one, try to work this one, see what you can get. If you get stuck, turn the video back on again, and maybe I can give you a little assistance. Okay, so if you're having problems with this one, we know that this arc right here is x. How much is a whole circle? A whole circle is how many degrees? It's 360. So that means this arc over here is 360 minus x. Now go put these, pause the video now and put these into your formula and see if you can work the problem. All right, so 54 degrees equals the arc big, which is x, minus the arc small, which is 360 minus x, all over 2. So 108 equals, just like that last one I talked about in the last page, you probably did not distribute this negative correctly. So it becomes a positive, negative, and a positive. And so I get 2x minus 360 plus 360 plus 360. 468 equals 2x. X is equal to 234. And that is the measure of x, 234. Okay, so in class we'll be doing pages 14 and 15 and starting on circle puzzle number 1. If you wanted to start circle puzzle 1 tonight, it might be good. You might come with some questions tomorrow in class and have some issues with that. And that is it.